Greetings and welcome, friends. This is part 2 of the 3.5 video about Slope-Intercept Form. Man, today is a good day, friends. We've talked about slope as being the rate of change, the steepness of a line, the rise over the run, the y2 minus the y1 over the x2 minus the x1, son. And it has been amazing. And now we're going to talk about representing lines with a particular equation. It's going to help us out. It's going to be great. So check this out. This was right at the tail end of the video yesterday, but we're going to pick it up here and do some different examples than you might have seen at the end of that video. So here we go. Slope-intercept form. This is one way of representing the equation of a line. We currently know standard form. So these two things can represent the same thing, just different ways, okay? So that's just perfectly fine. We're cool with that. Oh dear! There we go. All right, it came back. Don't worry. So a linear equation written in the form y equals mx plus b is in slope-intercept form. The slope of the line is m, right? M, good stuff. And the y-intercept of the line is b, okay? So there's my b right there. So b is the y-intercept. That is the location the line crosses the y-axis right there. That is also going to be the starting point for us once we try to graph using slope-intercept form. Here's my pitch though, friends. You ready for this? Get ready for this. This is my analogy. For the equation of a line in slope-intercept form, the m and the b are like the DNA of the line, okay? So the m is what determines the steepness of the line, just like you might have a series of genes that determine your eye color or something like that. And the b affects the y-intercept of the line. And in the future, if I talk about lines that are, say, have the same m gene, there will be a graphical similarity where that would be all lines that have the same slope. And if I talk about the lines that have the same B gene, that would be talking about all lines that would happen to have the same y-intercept, okay? So that's like, those are the two components of the DNA of any line. I can represent all non-vertical lines, so in this case, all linear functions as y equals mx plus b. All right, and those are the two components that we're going to be looking for that are going to help us out. So the m represents the slope, which in case you don't remember is the rise over the run. Rise over the run. So in this case, this one would have like a rise, and this one would have a run. Run. And the slope is slope, right? What color did I pick? I was kind of using green. I guess I should have. I'll plan out my colors better next time. The slope is equal to the rise over the run. Right? Oh man, I'm all over the place with my colors today. Rise and run. Right? So, those are the two components I need. Y-intercept and slope. The first problems I'm going to have us do are ones in which we are practicing just being able to recognize what those are by looking at the equation. All right, so let's just do that. So if you flip the page a couple, you'll find these. If you watched yesterday's video, I did not do these examples. These are extra ones for you, I believe. So here we go. If I want to find the slope of this equation, first of all, is this solved for y? Is y by itself? Yes. This appears to be in the form y equals mx plus b. And the m is going to be the coefficient of the x. All right, so there's the m right there. So my m is going to equal the -6, the sign included. The b is going to be the constant, all right, the thing that's being added or subtracted once it's been simplified. So my b here is going to be includes the plus sign. It's a +1, all right, or I don't have to write a +1 here, but if it was negative, I would have to write the minus sign. Okay, so that's the slope and the y-intercept, m and b. So all we're doing right now is, can I look at it and figure out what those pieces are? And that's one of the conveniences of slope-intercept form, is you can just look at it and immediately have information, a visual in your head of, this is where it crosses the y-axis, this is how steep the line is, oh, it's a negative slope. All of this information comes to you just as a result of kind of like seeing the Matrix, Neo. Man, that's second Keanu Reeves reference today if you watched the homework video. That's weird. That's weird. Let's see, this equation. You guys would recognize this, perhaps, it's been a couple days, as a horizontal line. Okay, if you remembered all the stuff about standard form, y equals 8 is a line whose y-intercept is at 8 and it's horizontal. Now, if I wanted to think about this in slope-intercept form, I could have thought of this as y equals 0x plus 8, because 0 times x is 0 and it would then not be written. If I write it like that, could you tell me what do you think the slope is of this line? What's the m? Yeah, the m is the 0. Okay, and what's the b, the y-intercept? Yeah, and the b is the 8. Okay, and even if I didn't rewrite it in this form, you guys actually might have already known that. You might have remembered that horizontal lines have 0 slope. We talked about that in yesterday's video. But I just want to point out that it's verified if I happen to force it into the slope-intercept form, writing this piece that I don't technically need. Okay, so 0 slope is a horizontal line. There we go. All right, this equation, problem, this is not in slope-intercept form. But if I switch it to slope-intercept form, that would be great. Then I'd be able to know the slope and the y-intercept. This right now is in standard form. So to get it into slope-intercept form is always solved for y. So let's subtract x from both sides. Let's get everybody away from the y. Why, oh why, must I get the x away from that guy? Here we go. So I subtracted x from both sides. Now how do I get the y by itself? We don't want to do this, but we're going to have to do it. It's the only way to do it. What do? Y is being multiplied by 4. What's the inverse operation? Well, my goal is to get this written in slope-intercept form, which is y equals mx plus b. And since this one isn't yet solved for y, I can't tell what the m and the b are just yet. So m, for instance, would not have been the 1, and b, for instance, will not end up being this -10. So here, so once I get it swapped around, you'll see, and it'll be in slope-intercept form like this one was, and I'll be able to know what the m and the b happened to be. Okay, so to get y by itself, it's being multiplied by 4. How do I undo multiplication by 4? Yeah, divide, and look at, guys, this is going to be the long dark of Moria. Just work with me here. We're creating a world of fractions. This is a little ugly, but we'll deal with it. It's going to be okay. We're going to trudge through this. All right, so the 4's cancel out. I get y by itself equals. Now, -x over 4, watch this. I'm going to write that as -1/4 x. The x is kind of just on the side. It's at the level of the fraction bar. It's definitely, do not accidentally write it in the denominator, but I could either have x in the numerator or x on the side, okay? And this coefficient, there was an invisible 1 there. So that's where the -1/4 came from. I'm trying to write it like this so that the -1/4 will really look like an m to me. That's the reason I'm doing that. And let's see, -10/4, I can reduce that fraction. Both of those are even. 2 goes into 4 twice and into 10 fifths. I don't know. So I'm going to have -5 halves. So here's my slope-intercept form. I agree that it's not pretty, but notice, what is the slope? What is m? Yeah, -1/4. It's the number in front of the x. That's referred to as the coefficient of a variable. The number in front of the variable is called a coefficient. And what is the b? It includes that minus sign. It's -5 halves. Okay, so I know that's a little bit weird, but that is, in fact, what we've got. All right, let's keep going. So we are able to identify the slope in the y-intercept once it's in that form. But let's put this to use, friends. This is going to be so much better than making a table of values. Oh my goodness, you'll wish you never made a table of values. Although, table of values, you are still valuable. Value is in your name. You can't have valuable without value. But my life, I'm going to move on and start graphing using slope-intercept form whenever possible. So, here we go. Example 4, I think you guys got this. Question? Oh, the b was the -5 halves. Sorry. Yeah, -5 halves. All right, it's the constant, right? Because that would have been in the slot of b in that location right there. So, using slope-intercept form. Those jerks! That's not in slope-intercept form. Do I have to do all the work, guys? All right, to get it in slope-intercept form, we got to solve for y. So I'll subtract dos equis. Nope, never mind. Don't drink alcohol, friends. Let's see, there we go. 2x's, subtracting 2x's from both sides. Y equals -2x plus 2. What is my m? What is the m now that this is in slope-intercept form? The m is just the number, m is -2. And if it helps, you could think of that as being -2 over 1 if you want to think about rise and run. Okay, so you could think about it like that if that helps you. Question? Why? Well, the problem was they gave me an equation, but it was in standard form. I want it in slope-intercept form, which means I had to solve for y. So I subtracted 2x from both sides. Even though I wrote 2x underneath this 2, I was kind of imagining sliding it right in there, which is what I did. And that's what I got. So once it's in y equals mx plus b, now I was able to find the m. What is the b? Anybody? Yeah, Tyler? B is 2. Yeah, the y-intercept is the 2, right? And it's positive in this case. So now if I want to graph, this is where this is going to be so much better than other methods, okay, making a table of values. We start at the b. I actually really like this. Ready? M and b. B, I had another teacher call that the beginning. All right? B for beginning. That's where I start. Okay? And then the M is the move. All right? So I'll move by my slope, but I begin with the B. Okay? All right. Right. So a y-intercept of 2. Here's a graph. How do I find a y-intercept of 2? Where does that happen? Well, I start at the origin. A y-intercept of 2 is going to be where the graph intersects the y-axis. And so I'm going to go up 2, 1, 2. Right there is my y-intercept of 2. I could also have thought of this as being the point 0, 2. Okay? So that's where I began. Plot your point wherever it would have happened to be on the y-axis. Next thing, I move by the slope. And this slope has a rise of -2. So I'm going to rise from the beginning, not the origin, from the beginning, from the y-intercept. I'm going down 2. And it has a run of what? 1 and over 1. Okay? And I'll plot a new point on my graph. So I moved by the slope. And also, watch this. If I want more than 2 points, because that's not a bad idea, I'm going to move by the slope again. Watch, from this point, down 2, over 1. There's another one. Down 2, over 1. There's another one. Down 2, over 1. The slope is the constant rate of change forever, so I could just keep getting more points. Down 2, over 1. From any one point, I could find another. And so now if I want to graph the line, let's see, what color was I? I'm kind of running out of good colors here. I guess I'll just use the green. So now I could draw. Yeah? Something like that? No, actually, let me just pick this point so I don't get scared and confused. All right, so this purplish blue, you're thinking? Yeah. All right. So here is the equation. Here's the graph of the line. And using slope-intercept form, it was so much easier than having to find a whole bunch of points and plugging them in. All I had to do was figure out what's the y-intercept, what's the slope, plot the y-intercept, move by the slope. Down 2 over 1. Down 2 over 1. They asked this other question. Now they ask, what is the x-intercept? The x-intercept, I can't tell from this equation. I also can't tell from this equation. The x-intercept is where it crosses the x-axis. Where did this appear to cross the x-axis? What point does that appear to be on the x-axis? It looks like it's 1 over from the origin in the positive direction. So the x-intercept is 1. I also could have, the x-intercept is only 1. I could have thought of it as the point 1, 0, right? Y-intercepts have 0 for their x, x-intercepts have 0 for their y. Yeah. Remember, we also know how to find an x-intercept. If I was to plug in 0 for y, I'd get 2x equals 2, divide both sides by 2. I'd get 1 that way as well. That was back from a couple, no, I guess that was only 1 lesson ago, or 1 section ago, 2 lessons ago. All right, so it's possible to get the x-intercept from the graph that way. It won't always land nicely on the graph, but there you go. Let's see. I just want to practice a whole bunch of these today, friends. Let's see. Here we go. It's gonna be great. I'm gonna do these ones a little bit faster, okay? Just so that way we get some nice examples here, because it'll start to click the more we see it. Once our brain sees the pattern, we'll be golden. Let's see. Is this one in y equals mx plus b? Yes. Is this one? No, it's not solved for y. So I'm gonna solve this for y first. So let's see. So I'm just gonna go through all of these. Y equals negative 3x minus 3. Y equals mx plus b. Question 11. Is that solved for y? No. So I'm going to get rid of the x. Let's move this x. And let's see. So I'd have something like that. How do I get y by itself now? Being multiplied by 2. What's the inverse? Divide everybody by 2. Everybody. Okay? So this one would be y equals, I want to think of this next thing as mx, so I'm going to write that as negative 1/2 x, okay? And 6 divided by 2 is what? 3, perfect. So now I've got 3 equations in y equals mx plus b form. Let's do the slope for all of these first. Austin, what's the slope here? What's the slope? It's the coefficient of the x. It's 4. 4. All right, let's see. Kayla, what's the slope here? I know you're still writing. Then, actually, yeah, you had a pretty good guess, because even if you were saying the wrong thing, you might have had a false negative, false positive thing. But yeah, the negative 3 in front of the x is our coefficient, so that's our slope. We also we can think of these slopes as being over 1 if you want to really think about it in rise over run form. Let's see, Tyler, what's the slope on this one, do you think? Yeah, negative 1/2. So the rise over run, it's going to go down 1 over 2, down 1 over 2. All right, let's see. Let's think about y-intercept. Okay, Austin, y-intercept for this problem? Actually, better yet, it includes the negative, so it's negative 4. All right, Makai, I know you were absent yesterday. Do you think you could spot the y-intercept on this one? Yeah, it's the plus b, right? In this case, it's minus, so the b must have been -3. Well done. And let's see, Kayla, what do you think the y-intercept is for this one? Well, let's see, the slope was this, so y equals mx plus b. So what's the plus b? The 3. Yep. All right, so let's start graphing these real quick. Y-intercept is -4, so I'm going to go start at the origin, go down 4. 1, 2, 3, 4. There's that y-intercept. Let's move by my slope. Ready? So I'm going to go, the slope is 4, or 4 over 1. So from the beginning, right? I'm going up 4 over 1. There's a point. From that point, go up 4 over 1. There's a point. Up 4 over 1. There's a point. Okay? I also can actually go backwards. I can go down 4, backwards 1. And the reason that's true is because -4 over -1 is equal to 4 over 1. So you can actually do a down 4, backwards 1 and still land on the line. So let's see. So if I want to graph this, I would just connect some dots, connect some dots. That's not at all where it is. All right, and this will represent all possible solutions of the equation. So there's my line. Okay, let's try the other one. Find the b. b is -3. So from the origin, y-intercept is -3, down 3. 1, 2, 3. There we go. Now the slope is -3. So from the beginning, I'm going to go down 3 and over 1. Right? Rise over run. Down 3 and over 1. Okay? Down 3 and over 1. And -3 over 1, I want to point out, is the same as +3 over -1. So you could actually rise up 3 and then go run backwards. Also, for safety, don't run backwards, friends. Just for safety. So I could also go up 3. Yeah, we don't want you to trip and get hurt. And so let's draw this line. So I'll connect the dots, and every other point is gonna have spots. That doesn't, I don't know, that doesn't make sense. But I like my song nonetheless. Let's see, I'm gonna go for this lighter purple in this case. I feel like it shows up better against my dark background. All right, okay. Someone want to verbally walk me through this other one here? My y-intercept is -3, or +3. So where do I go? I'm at the origin. Who's brave enough? Who thinks they can tell me what to do? Well, I start at the beginning. So go up 3, plot a point. And then let's see, the slope is -0.5. So in terms of rise over run, the rise is -1. So where should I go? Down 1. And the run is 2. So where do I go? Over 2. There's the point. Down 1 over 2. Down 1 over 2. Right? And then I can draw that line. Draw that line all the time. It's gonna be good. Also, you guys do have I do have graph paper if you want, if it helps. Right? And then there we go. Let's see. Quick. X-intercept. This one appears to be at 1. X in here appears to be at -1. Anyone have a guess on the x-intercept here? Looks like 1, 2, 3, 4, 5, 6. Looks like 6. Right? The x-intercept won't always land perfectly at a point, though, so be aware of that. So there we go. But there's our lines. Good stuff. We might, I think we'll end up spending one more day on this, especially since this was a half day, and the other problems are word problems, which we should at least spend a day on. So there's going to be a good news, everyone. There will be a part 3 of this video. So thanks for watching, Internet friends. Have a great day.